All right, so this is an ALEKS topic that's called predicting precipitation, and this is a really fundamental topic that you definitely need to grasp and need to be comfortable with. I did find a few inconsistencies or things that I really don't like about this problem, and I'll talk about those and how to alleviate those as we go through this video. I'm going to go through two sets of examples just to make sure we cover a lot of different things. You are going to need a list of the solubility rules, so this table of your solubility rules. You can find one in one of these data tabs or whatever, but I think just grabbing one from one of the handouts is a good thing to do. So this is the one that I'm going to be using for this problem. And let's get started. So basically what we're asked to do is we're mixing together ammonium nitrate and sodium acetate, and we need to figure out, will a precipitate form? So what I would really recommend you do is write out, so step one or number one, write out what is ammonium, right? And then write out what is nitrate, and sodium and acetate is C2H3O2 minus. And then we're going to see if we can figure out, if I mix any of these two things together, will it be a insoluble compound? So that would be a precipitate, would be an insoluble compound. And right away, I'm going to see that ammonium and sodium, these are part of the first two rules, and compounds with those will always be soluble. So right away I can tell, no, a precipitate will not form in this case because I've got, my cations are ammonium and sodium. There won't be any precipitate formed. The next one I've got manganese chloride. So manganese is Mn, 2+, so I'll get my 2+ charge there. Cl minus, nickel 2+, and then nitrate NO3-. So right away I know that the nitrate, it's not going to form any soluble compounds. That's my rule here. Nitrates are never going to form soluble compounds. So then for the chlorine, if I want to match the chloride here with manganese or nickel, so chlorides are going to be soluble. So make sure you guys can see this. Chlorides are going to be soluble, and these are the only exceptions: silver, mercury, or lead. And I do not have either of those cations, so there's again not going to be any precipitate in this case. For the last one, now I see this zinc nitrate, and this is the thing I don't like about this problem. This should really say zinc 2 nitrate, right? Zinc is a transition metal, so we really need to be identifying what the charge on that transition metal is. So this is an inconsistency. This is a problem with ALEKS, which is not good. But there's an easy way for us to sort of figure out what's going on there and figure out how to solve this problem properly. So I'm going to do the same thing. And if you aren't sure what this charge on zinc is, you could just leave that off for now. I think that's okay. But I've got all my other things. The nitrate obviously is not going to form any sort of soluble compound or insoluble compound. Sodium, again, is also going to be always soluble. So the only choice here is zinc hydroxide. Maybe zinc hydroxide is going to be something that's insoluble compound. So hydroxides are insoluble. The exceptions are going to be group 1 alkaline metal ions, that's group 1, and barium 2+. So zinc hydroxide is going to be a precipitate in this case. So we'd say yes. This would be my empirical formula that I would plug in right there. And in terms of the charge on zinc, right, if we just look at this, we're not told what the charge on zinc is. So we might think that this could be a +1 charge, right? Nitrate is -1, so it's very reasonable for us to think that zinc could be +1. So what I would recommend, if you run into this situation, you're not sure what the charge on zinc is, and I've noticed this inconsistency with zinc and also with cadmium. I saw another example where cadmium, they did not give the charge. Just Google it. Just type in zinc hydroxide. We know that the name for this would be zinc hydroxide. Type in zinc hydroxide to Google and see what formula you get. Whatever formula you get, that's what we're going to put here. For the cadmium case, for a different example that I saw, I just did the same thing, right? Just type in, it was cadmium chloride, was going to be the compound, or potentially be the compound, and I can see that right away that cadmium has a 2+ charge. So a little bit of extra work there to figure out what the charge will be, but I think it's worth it, right, to make sure you get them right. Let's do one more set just to make sure we're understanding what's going on here. So here, I'm not going to write everything out. I'm going to go through a little bit more quickly for this. Basically, I'm going to be seeing if iron, and I'm going to switch it with the other species, if iron sulfide would be a precipitate. So sulfides, that would be insoluble. The exceptions are group 1 and ammonium. So iron sulfide will form a precipitate. So in this case, it's going to be iron 2s3. And I'm coming up with this iron 2s3 because of the charges. If I've got iron with a 3+ charge, sulfide, that's just going to be s2-. That's going to be the thing that I need to balance out. So it should be 2 irons for every 3 of those s2-. Next is zinc hydroxide again. So sodium nitrate, obviously that's going to be soluble. Zinc hydroxide, that's going to be insoluble. So zinc OH2, that's the same one we had on the previous problem. And again, this should say zinc 2, but because it doesn't, we can just look that up and find what the charge is. So we are going to run into that problem with this ALEKS topic, and I'm sorry about that. It's not my fault, it's ALEKS's fault. And then potassium carbonate and lead nitrate. So here, potassium nitrate, obviously that would be soluble. We've got potassium in group 1. So then lead carbonate, carbonates are insoluble. Lead is not one of these soluble exceptions. So this one, all 3 of these precipitates going to form. Lead is Pb, and then lead 2, Pb2+, carbonate has a 2- charge, so just PbCO3. That's all we need to put there for the empirical formula. All right, hopefully that makes sense. If not, definitely let me know. And again, sorry about this zinc with the 2+ charge not being specified. Same with cadmium is the other example. If you find other examples, feel free to let me know.